I've had a few people ask me for the answer key for this, and I don't have it online, but I wanted to walk through one of these with you because I would have done that had we been in person in class. And so that way that can help you. And just know that when we do return to class, you will be able to check the answer key before you turn it in. I'm going to make sure that all this stuff that you've been doing on your own makes sense so that we know what we're doing before we move forward. All right. So I would like to just do, you only have to pick 3. And I thought that we could do number 3 together on the back side. I would strongly suggest doing number 2. And why I suggest number 2 is because everything is +1 -1 charge, and it's so much easier when it's already balanced when you write that out. So number 3. Iron 3 nitrate is added to sodium hydroxide. So just a little rundown. The M part is just like the regular balanced equation that we have been doing this whole chapter. Okay, these are all double replacement reactions. So we will need to write it so that you do the outsides and the insides to make the products. Okay, so iron 3 means that iron has a +3 charge. Nitrate, maybe we have that memorized now, is NO3 -1, but you can also find it on your back of your periodic table. So iron 3 nitrate will be Fe parentheses NO3, and then the charge of iron goes on the outside like that. And then it's added to sodium hydroxide. Sodium has a +1 charge, hydroxide has a -1 charge. So just NaOH for that. Okay. And everything are in solution form as reactants. So those are both aqueous. Okay. Now for the products, we've got, here we'll do blue for 1. So iron is going to pair up with hydroxide to make one of our products. And so that is going to be Fe, and then inside parentheses is the OH, outside is a 3, because we have to have triple hydroxides due to iron's charge. And then the inside, we're going to do sodium first, paired with the nitrate. Remember, the positive ion always goes first. So, and those are both +1 -1, so that would just be NaNO3. Excuse me. Okay, so now at this point, we still need a couple things. We need to balance it, and we need states of matter on our 2 products. So nice and easily, let's balance first. And these are all polyatomic ions, right? So we're counting groups of polyatomic ions to help speed up the process. So we have 3 hydroxide groups on the product side. So that means I'm going to put a 3 in front of the NaOH, and that makes 3 sodiums. So I put a 3 in front of the sodium nitrate, and that makes 3 nitrate groups, which is okay because we've got 3 nitrate groups, which is all good. Okay, so now it's balanced. Last but not least, we need states of matter. And the reason why we need states of matter is because we cannot do the other 2 equations if one of them is not a solid. So we need to look at our back of our periodic table at our solubility rules, and you might, do a process of elimination, figure out which one's the aqueous, and then the other one has to be the solid. Okay, so sodiums and nitrates are always soluble, which means that the NaNO3 is going to be the aqueous product. And so by default, the iron 3 hydroxide will be the solid product. Now, you also could probably go down and read that most hydroxides are insoluble unless they're paired with certain things, but the iron 3 hydroxide with iron is not a exception. Okay, so these are all worth 6 points, and that was just 2 points right there. Okay, so now the complete ionic equation, what that does is you will break up anything that is labeled as aqueous. Okay, the solid stays together. So sometimes students like to box that if that helps you to remember that the solid does not break apart into its ions, but all of the aqueous, so you'd have three things that are labeled aqueous, must get broken up into their ion form, and it has to stay balanced. So this one takes a lot of writing. Okay, so the iron 3 nitrate, it's going to break back up into these ions that we wrote at the beginning. So it'll be Fe plus 3, and everything gets its own state of matter, aqueous, plus now this 3 will go in front for balancing purposes, just show that we have 3 nitrate ions labeled aqueous, and then you just keep adding things. You don't have to put anything special. So then the 3 sodium hydroxides, that 3 goes to both parts. So plus 3 sodium ions labeled aqueous, plus 3 hydroxide ions labeled as aqueous. Okay, so that was just the reactant side. Now for the product side, the solid stays together. So I'm going to just write it in a different color so that helps you see that it stays together. All right, but then our last product happens to be aqueous again. So that needs to be broken apart, and that 3 needs to be distributed. So 3 sodium plus 1 aqueous plus 3 nitrate minus 1 aqueous. Okay, so that is the complete ionic. All the aqueous get broken apart, the solid stays together. So you need to have charges on all of those ions, all of the broken apart things. Okay, and last but not least, then the N stands for net ionic, where how we figure out the net ionic is the only product that we should have is the solid. So the other 2 parts on the product side from the complete ionic equation should cancel out with their ions on the reactant side. So basically you cross out things that are the same on both sides of the arrow. So like the 3 Na plus ones get canceled out, and the 3 NO3 negative ones get canceled out. Okay, and then you write what's left over, what you did not cancel. So I'm writing it down here because I kind of ran out of room, but it would be Fe plus 3 aqueous plus 3 OH minus 1 aqueous. That's all that was left on the reactant side, makes our solid FeOH3 solid. And the way to check yourself to make sure you did it right is that the 2 ions on the left should add together in the correct balanced way to make that solid product. If that doesn't happen, then you did it wrong. Okay. One other mistake that I have students do is they'll do the whole process and they figure out, you know, like write out the complete ionic and cancel out the spectator ions, but it all is wrong because they will accidentally label the aqueous product as the solid product because they don't remember that soluble means aqueous. So just be careful with that. Make sure that you're going to do it right. So again, you'll be able to check before you turn it in when we get back to school.